Hi and welcome back to my channel. In the previous video we saw how to create this map, which is showing the distribution of observations of grey wolves in the Iberian Peninsula using data of the GBIF database from the years 2013 to 2024. And you can see that the areas where we have a higher density of observations is in the northwest of the Iberian Peninsula, but we also have a high density here, also in the southwest and other areas. And we created this map, which is a static map, and this week we will use the same data to create an interactive density map. And the final result will be this map that we have here, which is using the mapbox API. And with this map you can zoom out or zoom in and you can see that the density map will adapt. So if you zoom in you will see where these observations are also distributed more clearly, and you can play more with this map and even use your right mouse button to rotate the map. Alright, so this week we are in the 8th script of this GitHub repository that you can find in the comments of this video, and I will enter here and we will have two different scripts. We have the prepare wolf data script, and I will go very quickly throughout it because I already explained it in the previous video and you can see all the details in that video. So here I'm basically using these different packages to get our study area. So I'm using the Gisco R package to get the study area, which is the country of Portugal, the country of Spain, and then I make an union to get the Iberian Peninsula. And then here I get the data of the wolf observations from the GBIF database using this function. And finally I get the digital elevation model. And I repeat, you can find the details of this part of the script in the video that I published in the previous week. So we will go directly to the second script, which is wolf density map. So here I will start loading the pacman package, and in the case that you don't have the mapgl package, you can install it by using the pack package and the pack function. So here we need to install it from the GitHub repository because this package is not in CRAN yet when I'm recording this video. So you need to install it from GitHub. So if you execute this, it will find it in GitHub and it will find the latest version of the package. In this case, I already have the latest version, so no downloads are needed. And then we will load the rest of the packages. So we will use the geodata package, which is used to get the GBIF data and the digital elevation model, the GSCOR package for getting the study area, the mapbox API, which we will use in this line of code to get our API token from the mapbox webpage, the mapgl package, which is used to create the interactive maps from the mapbox API. And then we have these packages for vectorial data, raster data, and for data in general, for data analysis and for visualization. So the first step is to get our mapbox API token, and we need to use this only once. So we will go to the mapbox API, create an account, and paste our token here. And once we have our token, we will use this install equals to true, execute this line of code, and restart our session so it will take effect. So to create an account of the Mapbox API, you must go to mapbox.com, and here you can hit in this button, get started for free. So in my case, I already have an account, so it's already logging in, but in your case, you will have to create an account from scratch. And once you create your account, you will be here in your dashboard. And you can see here that I already have here a token. In the case that you don't have any, you can create one by hitting in this button. And once you have the token, you can copy it and go back to RStudio. And once you have your token, I will go back to this script, you will paste it here and execute this line of code. And once you execute this line of code, go to session and restart your R session so you will be able to use the mapgl package. In my case, I already did this before, so I will comment out this line of code and continue with the code. So here what I'm doing is to source the other script that we saw previously, so I will execute this, and what the source function will do is to run all the code that is inside this script, so it will get all the data. Before continuing with the rest of the script, I wanted to note that the function that we use, the mb access token, will only work for the current project. That means that you can restart your session and you don't have to execute it again in that project. But if you create a new RStudio project, you will have to execute that function again, because that function what is doing is to create the .renviron file and storing the value of your mapbox API token in that file. But that can be a bit tedious because you have to execute it once again when you create a new project. And one way to avoid this is to go to your environment variables. So here you can write environment and you will find something like this. Edit the environment variables for this account. So you will find this table here and you can create a new variable. So I will hit here in new and I will give it a name, and the name must be mapbox underscore public underscore token, and the name must be exactly like this, and you will paste here your token. You will hit in accept and you should have your new variable here, and you will accept again, and now you should close RStudio and open it again. It won't work if you restart your R session. You need to close RStudio and open it again. So after a couple of minutes, we should have everything loaded into our environment. We have a total of 6 different objects, but in the end we will only use this wolf SF. But here we can visualize the study area, which is this Iberia SF. So we are taking the geometry and then plotting it. Then I'm adding to this plot the digital elevation model, which is a spat raster object, which is the one that we used in the previous week video. And then I'm adding the wolf SF, which are the observations that we have from the previous decade. So we will use this data to create the density map. So to use the mapgl package, we can create a basic map just by using this function mapboxGL. So I will execute it and it should show you the earth, and you can zoom in to different areas. I will go to my town so we can see how this works. And you can see here in the basic map, if I use now my right button, I can rotate it, and you can see the height of different buildings also. So this is pretty cool. So to this function, we can add different arguments such as this style. So I will comment out this other comment so we can see each one at a time. So I will execute this part of the code. And now if I zoom in, you will see that now we have a different map, which is this outdoors one. And in this one, if I zoom in and I come here to this school, we can see that now we don't have heights because those are specifically from the previous base map. And in the case that you want to check the different options that we have to introduce here, just write something random and I will execute this part of the code, and the error will give you the different options that you have to introduce here. So let's say that we want to introduce the satellite, for instance, and I will execute just this part of the code. You will see now this satellite image. So now we will see the other arguments. If I uncomment this center and I execute it again, now we have the Earth centered to these coordinates, -7 longitude and 42 latitude, which is approximately in Galicia, so right here. And then we can use also this zoom argument. So if I execute this part again, you will see that now we are zoomed in. And if I increase this to 10, let's say, and execute it again, Okay, it's only this part of the code. Now we are more zoomed in. So I will change this back to 5, and then we will see this function fly2. So what this function will do is basically what it's saying. It will fly to these coordinates. So it will start from this one, which is exactly the same, and what it will do is do one effect of zooming in. So if I execute everything now, you will see that we start in the zoom level 5 and we go to the zoom level 10. And here I can change this, for instance, to 70, let's say, and I will execute it again, and you will see that now it will make that nice effect. But now I don't want it like that. I will just leave the same coordinates and execute it again. Okay, so now we will see how to add a heat map to this map. So I start again with the mapboxGL function. I use the dark map style in this case. And to add a heat map, we just need to use this function, add heat map layer. We need to give to every layer that we add to the mapgl package an ID. So in this case, I'm calling it Wolf's heatmap, but you can put whatever you want here. And the source argument is for the data, which must be an SF object. So if I execute everything now, you will see this big dot here. And when we zoom in, you will see that these dots will start to separate, and they will be in the areas where we have more observations. So here we have many observations of wolves, while in these areas that you see here, these blue areas, is most likely that we have only one observation. So now I will zoom out and we will go to the second heat map. So here in this case I will use the mapbox style satellite again. So it's this one here, and I will use this function fitBounds. And what fitBounds will do is basically what this function is saying. It will fit the bounding box to the bounds of this object, which is basically the Iberian Peninsula. Actually, in this case, I'm thinking about it now, we can just add the Iberia SF object, and I think it will be better because it won't be closing so close to the border. And it's a bit more separate, not very much, but I think a little bit, yeah. So now here I'm adding again a heat map layer. I'm giving it the same ID, the same source, and I'm adding a new argument, which is the heat map intensity. And to these functions, we can add this interpolate, and we can add here either a property or a column of the data to interpolate the intensity of the heat map. In this case, the intensity will be interpolated depending on the zoom level, and here I'm giving some values and some stops. And first I will execute it, and then we will see what is it. Well, first I will explain this opacity is basically the transparency of the heat map. So if I say 0.1, you will see that it's almost transparent, and if I say 1, it's opaque. So in this case I'm using 0.5. Okay, so we will go back to this heatmap intensity argument. So we are interpolating with the zoom level. Here we need to specify some values and some stops. So the length of this vector should be the same length of this vector. And in this case, if I increase the second number of the value, so let's say that I put here 50, you will see that we lose intensity of the density of the different points. So we need to have a greater number of points to show it as a red area. So here you see that before we had some reddish areas, but now we are being more conservative in that way. And if we increase the stops, it will be the opposite effect. So let's say that we have 100, for instance, which is very much. You will see that each of the points will have a greater contribution. So if I zoom in, you see that in these areas we have only 1 point, but they are contributing very much. So this is not very good to have. So it's better to have maybe, let's say, 5 in this case, or maybe I will put 2, execute it again, and I think it looks nicer like this. And here I can maybe increase this a little bit to 10. And yeah, I think this looks better. And now we can go to the final map where I'm adding the flying effect with this fly2 function. So I'm centering it to the coordinates of Madrid. I'm saying this zoom level 5 and the rest of the arguments are exactly the same. So I will execute it again and there we have our nice effect. And this is the final map and we can explore it, we can use the right button, we can zoom in, we can rotate it as we want, and I think this is very nice. And this map is, I think, on the ways to CRAN when I'm recording this video, so maybe when you will watch it, is the mapgl package is already in CRAN, but for the moment you need to install it from GitHub. And if you want, you can also export this web map by using this export, save as web page, and I will go here to wolf density map, and here I have these two. So I will overwrite this one, I will replace it, and I will go back here. Well, it opened already, and here we have our map in HTML format, so we can put it in a website.